let me start out by explaining that I have a couple of teenage daughters, and yet, ironically, the thing that I worry about the most is not them, but this. I worry about the standardized tests that we use in the United States in particular, although in other parts of the world as well, as the measure of schools and learning and teachers and everything relating to education. Now, to be fair, there are some things about standardized tests that are really good. Here's one of them. When you give a standardized test, at the very end, you get a number. And it turns out that numbers are really easy for people to interpret. So if I get a 416, that's not as good as if I get a 516, but it's better than if I get a score of 316. And so for policymakers and for parents and for teachers, it's easy to judge performance based on a numerical score. The other thing that standardized tests have going for them are, well, they're standardized. Meaning that at least in theory, everybody has the same chance to do well or to do poorly on the exam. Now, that having been said, there are some properties of standardized tests that are problematic. One of them is they kind of parachute in from nowhere. So on one particular day of the year, you sit down and you take a test in math or in whatever the subject is, and based on your score on that one day, and not even one day, it's usually 1 hour of one day or a couple of hours of one day, we judge somebody's entire year's worth of education. We judge how good they are on a subject. We make all kinds of decisions based on this very small piece of information. And of course, just on the face of it, that doesn't make much sense, right? On a particular day when a test is being taken, if you don't feel well, you won't do as well. That doesn't mean that you know less than if you felt better. It just means that on that particular day you didn't do well. In a sense, we can think of these tests as like taking a little snapshot, just a quick picture in time of what somebody knows and what they can do, and we're making our judgments based on that. And of course, as everybody with an iPhone knows, every once in a while we all take a bad snapshot. And worse, it's a snapshot that focuses only on a very small part of what it is that we know and what we can do. So the likelihood that that snapshot will be a poor representation of the individual is actually really high. The reason that we do this is, of course, that we have a theory of learning, an idea about what it means to know things, that's based primarily on skills and knowledge, on isolated pieces of skills and knowledge that float around out there with the idea that we're going to assimilate them, and then later on we will assemble them into some kind of complex performance in the real world. And of course, what these tests are doing is selecting just a few skills and knowledge out of all the ones that they could test. And worse, they're not even actually making very many connections between them. They've been designed to try and isolate whether or not I have A, B, C, D, but not E, but F, and so forth. It's almost as if we built our entire school system like it's a scavenger hunt. So we send children up and down the beach of knowledge, picking up pieces, and then we test them by asking them to show us which pieces of knowledge they've collected over time. I sometimes refer to this as the Bricks-and-Mortar theory of learning. So what we do is we give kids a lot of bricks, right, with the idea that they will carry them around for a while, and then when they finally need to build something, they'll have the bricks. Of course, the bricks are heavy, and the kids don't really see much point in carrying them around, so they lose them along the way, and basically just what you'd expect if you gave somebody a bunch of bricks with nothing to do. Now, if you believe that this approach to learning doesn't have consequences in the classroom, let me offer you a few obvious examples. So everybody knows that we live in the age of Google Maps and Google Earth and Apple Maps, and in fact there's arguments over which maps give you the best representation of the world in your pocket. As an educator, I thought, well, this is great. We have these great tools. Imagine what we are doing in geography classes and in history classes. So I went online and I looked up an assignment from, this is a college level geography class. Here's the assignment. It's a map of ancient Mesopotamia. And what you're supposed to do is fill in things on the map of ancient Mesopotamia. So you get 1 point, for example, for identifying Babylon and Ur and the Persian Gulf. You get 1 point for titling the map Ancient Mesopotamia and for having your name clearly displayed. You get 1 point for shading the water areas with an appropriate color. I assume is blue, except maybe for the Red Sea, I don't know. And you get the most points, 3 points, if the map looks neatly done. If we turn to educational technology, we see things like Math Blaster, one of the most popular education titles, at least in the United States. For those of you who aren't familiar with the game, you fly through the universe, solving problems and overcoming challenges like finding the sum of 30 and 10. There's nothing particularly unique about Math Blaster. This is the game Zombie Division. You travel through a dungeon killing zombies by finding their proper factors. There's games to learn spelling, games about Bible verses, not so popular in schools in the United States as you might imagine. This is one of my personal favorite, Typing of the Dead. And what these games all have in common is this. They're all about mastering the basics. They're about learning basic facts and basic skills. In other words, they're about learning to pass these standardized tests. Even the latest, greatest craze in education, the MOOC, the massively open online course, is essentially taking the traditional class and making it high-tech, with the idea that if we record the same thing that we've always been doing, we can make it available to lots and lots of people, and suddenly that will change the landscape of education. The problem with all this, of course, is that it misunderstands the fundamental nature of what a computer is doing in the first place. And here I'm going to be talking about some things that I talked about yesterday, so for those of you who want to check your email, go right ahead, you won't be missing anything for a bit. The key to understanding a computer is understanding first what a pencil does. So what writing fundamentally does is it stores information. I put something down on a list, the list remembers it so I don't have to. Computers do something very different. They manipulate information. They actually change things without me having to directly do everything myself. If you prefer the language of business, writing outsources memory. Computation outsources thinking itself. Let me give you a quick example of what I mean by that. When I made this slide, it didn't look like this. It looked like this, because as everybody who uses Microsoft Office products knows, that little squiggly line under a word means it's misspelled, because ironically, Microsoft doesn't recognize outsources as a properly spelled English word. Now there's nothing particularly magical about the way that it does this. It has a dictionary, meaning it has a list of words, and every word that I type, it compares to the list, and if it finds the word, it's correctly spelled, and if it doesn't find it, then it's not correctly spelled. Now, you might think, well, that's not such a big deal, but to me it's a big deal because I'm an academic and I make my living with words, and I'm a terrible speller, always have been. Which means that either I would have to spend my time with a dictionary looking up every one of the words to make sure it was correctly spelled, or I'd have to pay somebody else to do that, or I'd have to look foolish. But I don't have to do any of those things because now the machine does it for me. In other words, the computer outsources simple thinking so I can do more complex thinking. And this has huge implications for the curriculum. So for example, this is the algorithm for extracting a square root, for finding the square root of a number if it's not an even square root. This algorithm hasn't been seen in the United States for about 100 years. My guess is it probably wasn't in any of your textbooks in Sweden. I actually first saw it when I was teaching in Nepal. And the reason that this algorithm, which is sort of like long division only harder, hasn't been in textbooks in the West for about 100 years is that since about 100 years ago, slide rules were widely available. And it turns out that a slide rule is much better at extracting a square root and doing a whole bunch of other things than just pencil and paper alone. But in order to use a slide rule, you have to understand something about logarithms. In particular, you have to be able to read a table of logarithms, which means that, well, there's probably 3 or 4 of us in this room who, when we were in high school, we learned how to read a table of logarithms, and we learned a particular skill called interpolation, which is basically how you figure out what number to use if the number you want isn't on the table. It's really complicated. You take the number above and below and you add them and divide by 2. But in any case, this was taught in trigonometry class on the theory that once you were learning to read a table of sines and cosines, you might as well learn to read the rest of the tables, which in this case was the table of logarithms. Again, at least in the United States, like my children today don't learn anything about reading tables of logarithms and sines and cosines. Why? Well, because for 99 cents they can go into any drugstore anywhere in the world and they can buy a pocket calculator. Or not even buy one, they can just carry around in their phone in their pocket. Right? And this little key right here does all the work that in Nepal was an entire lesson in how to extract square roots, that used to be learning about logarithm tables, and now we're free to do something else with our math curriculum. In other words, before we had computers, people had access to only one computer. It was right here, inside their head. And in order to be able to learn to do something complicated, they first had to train their brain to do all the steps leading up to it. Which is why we think of a curriculum as a course. It's actually a directed set of things that move, in this case in the mathematics curriculum, from things that are less complicated, like counting and cardinality, to in the upper grades, things that are more complicated, like functions and expressions and equations. But in the age of computers, when the computer can do lots of these basic things for you, you have to wonder, why is it that at a university you have to take 1, 2, 3, 4, 5 courses to get to statistics, which is one of the most fundamental math concepts that people use in the real world every day. You read in the newspaper about statistics. And yet you have to take 5 courses in order to be able to even begin to interpret them. Or probability, its related cousin, takes 3, 4, 5, 6. It's 7 courses before you're going to learn anything about probabilistic decision making, and that includes 2 courses in calculus. We have an idea, based on the fact that we used to have only one computer, which was between our ears, that everything has to start with some fundamental basic knowledge, moving to something that's more advanced, until we finally have enough training to be able to deal with some complex problem in the real world. And the problem that creates is that from a student's point of view, they may be able to master the easiest first steps. The next steps become harder, and eventually they say, why are we doing this? I'm spending all my time learning about these bricks and I don't see the purpose. This is the typical student question. In other words, we start them off with the small details and they miss seeing the big picture. They've already tuned out by the time they would get there. But now with computers, because we don't have to train all of the basic steps at first, we can actually reverse this. We can start with the big picture. Kids like thinking about how the world works. They like role-playing. They like trying out things. And with a computer, they can start by doing those things and only later on uncover the lower-level details that the computer is using in order to make that simulation of the world possible. And in fact, what it means is that instead of starting with one set of details and eventually deciding which path you want to go down, there are actually lots of paths that you could take to get to those same details. And each child might find a different route that they want to take, that they find interesting and engaging, and that they can start out on because they have the computer. And there's another problem that the traditional sort of bottom-up view of education creates, and that is that it doesn't actually prepare people very well for the modern workplace. Why? Well, because it's based on some outdated ideas about how people solve complex problems in the real world that require innovation and creativity. Our society has a bunch of myths about what it means to be creative. Here's one of them. Right? The way inspiration works is we get our coffee, our favorite song, we get some free time, and inspiration suddenly comes. When in fact, the reality is that it doesn't actually work typically. We also have a kind of myth that the way that innovation works is that somebody goes off on their own and this idea just springs forth. Right? And of course, sometimes that does happen, right? Einstein was in fact Einstein. But for the most part, the way that people solve complex problems is in groups, is in communities of practice. Groups of people who have similar ways of thinking about problems, about framing issues, about approaching challenges, and about coming up with solutions. These communities of practice are essentially groups of people that have a shared culture. Now, what does it mean to share a culture? Well, it means, of course, that you need to know something. In order to participate in a community of practice, you actually have to have some knowledge. It turns out knowledge is important, and so are skills. But more than just knowledge and skills, a community of practice, the culture of a community of practice, also has values. There are particular ways that you decide, for example, which skills are appropriate to use in a particular situation. Members of a community of practice share an identity. They see themselves as doctors or lawyers or architects or engineers. And all of these things, skills, knowledge, identity, and values, are tied together by epistemology, which of course is a fancy word for a particular way of making decisions and justifying actions, a way of thinking, if you will. Now in my work, I've called this combination of skills, knowledge, identity, values, and epistemology an epistemic frame. And it's a useful metaphor because you could think of it sort of like a pair of glasses that you put on, and when you put on that pair of glasses, you see the world in a particular way. And different groups of people see the world from a different perspective. They wear different epistemic frames, and all of us have multiple frames. We have the frames that professional frame we're sitting in now. When we go home and or spend time with our family, we look at the world in a different way. If we meet with a group of people that we play sports with, we value different things. We think about the world differently. Now, the reason that all this matters, that it matters that, in fact, solving complex problems in the real world is about developing an epistemic frame, a way of thinking, a culture, is that games are cultures too. And let me give you a quick example of that. So this is what is one of my younger daughter's favorite games, or was for a long time. It's something called Webkinz. Webkinz being a very American game, you buy a toy and then a little stuffed animal, and the stuffed animal appears as a character in the virtual world. Now you can interact with your pet, so you can ask them questions. They can give answers that make parents cringe. The main mechanic of the game is buying stuff for your pet. So you learn how to use an online shopping cart, and you have to get money, of course, to be able to buy stuff. So one of the ways that you can get money in this virtual world is you can gamble. Another thing that you can do is you can play educational games. This one's called Booger Gets an A. You have to find the smaller numbers that sum up to a larger number, right? So in this case, you have to find two numbers that add up to 4. And when you're done, you get the usual positive messages about mathematics. You can, I kid you not, in this game, go to work in the mines to find gems. And then there's a host of other 21st century jobs that you can do, like delivering newspapers, being a personal assistant, being a shoe store clerk, and so on. Now, there's nothing particularly unique about this game. What this game is doing is exactly what I said a computer can do. It's creating a simulation of some world and letting people see the world through the lens of this simulation. And there's very little doubt that when kids play games like this, there's carryover into the real world. So, for example, this is the character creation screen from The Sims. You get to choose the hair of your character and the glasses that they wear and the clothes that they wear and so on. This was a recent birthday card I got from one of my kids. I think they were trying to tell me I was losing my hair. In any case, it's not so surprising then that companies and other people have started looking at ways to use games to teach people things that are going to matter in the real world. So for example, IBM a few years ago did a study of leadership in the distributed world. It was lessons from online gaming. So what they did was take a bunch of established business leaders and they had them play an online game. And then they were going to look and see to what extent the things that they used in business, they also saw in the game. This was the game they chose.
In a land of mighty kingdoms, a world awaits. The world of Warcraft.
Now, for those of you who think it might be a little odd to have business leaders playing the world of Warcraft, to be, whoa, now this is moving it by itself. That's not good. It's actually a fairly complex game, and turns out that it uses some of the kinds of skills that somebody would use in business. Things like applying virtual communication tools and facilitation techniques, using collaborative spaces, communicating where the organization needs to go, providing proof and guidance, and so forth. And so perhaps it's not surprising that something like 75% of the business leaders surveyed said the environmental factors within these games can be applied to enhance, what's going on? Can be applied to enhance the leadership effectiveness for a globally integrated enterprise. And here's the data they're looking at. So on one axis they have the percent of the people who indicated that something was relevant in the game, and on the other axis they have the percentage of people who indicate that it's important in the corporate world, and they're saying that, see, look, there are things that are high on both of them, particularly visioning and collaboration skills and so on. Now, being a bit of a statistician, I looked at this graph and I noticed that the axes are a little bit funky. So I took the data and I replotted it. So these same people said, 61% of them said the skills and techniques cannot be transferred directly to the leadership of the virtual corporation. In other words, there's stuff that happens in the game that's like stuff that happens in business, but doing it in the game doesn't necessarily help you in business. And why? Well, it's because it turns out that seeing the world the way somebody does in the world of Warcraft is not really the same as seeing the world the way somebody does who's a professional solving problems in the real world. What we know about professionalism is that professionals have a particular kind of thinking that Don Schoen has characterized as reflection and action. It's literally thinking that reshapes what we're doing while we're doing it. In other words, somebody who solves problems in the real world, complex problems, links the things that they know to the things that they know how to do. And this linkage between ways of knowing and ways of doing takes place in a professional practicum. And here you can think of, say, internship and residency for doctors, moot court for lawyers, architecture studios for graphic designers, capstone courses in engineering or urban planning or journalism. These are all places where somebody who's training to solve real problems, training to become part of a community of practice, takes action, but then systematically steps back and reflects on that action, talks about what works and doesn't and why, with peers and with mentors. And this cycle of action and reflecting on that action builds the reflection in action of the mature professional. In other words, the job of the practicum is to build this epistemic frame. So what if we took this idea, and instead of taking technology and doing the same thing that we've been doing before, only presumably on a bigger scale, we actually use as we know it. That's almost certainly not true, right? That in fact, everybody thinks about math the same way. It's just that they use different pieces of it. These practices, the things that people do in the real world, are just as epistemic as the disciplines from school. In other words, they have their own criteria for what counts as true, for what justifies the decision. A way to think about that, right, is that if I'm in an operating room and something goes wrong, the person I want to make the decision is a doctor about what to do next. Right? Once something's gone wrong in the operating room, though, and I'm out of surgery, and I want to sue because the doctor made a mistake, then I want to listen to a lawyer. Right? So in different circumstances, I'm going to let a different expert make the decision about how to proceed. And neither of them is doing anything that looks like history or science or anything like that at the moment. So the epistemology is there because the argument is not that this is vocational education, not that there's anything terribly wrong with actually learning to do something in the world that will make you money, but the point of having somebody role play as an engineer or an urban planner or a doctor isn't because everybody's going to be one of those things. It's because those are ways of thinking that people use to solve problems in the real world. So the idea would be to say, let's take the things that we want people to be able to do in the world, which are simultaneously ways of thinking about the world, and let's make those available to students right away because a computer can do that. Right? So what would it mean if everybody who picked up a newspaper or turned on the television understood how a journalist thought and why some stories get reported and others don't, why the news gets told the way that it does? What would it mean, well, at least in the United States, right, we spend a sixth of our national economy is spent on healthcare. What would it mean if everybody who went into a doctor's office actually understood something about the way medical decisions are made? That's the justification for this approach, is that it is fundamentally epistemic. So that's where those categories came from. Now, that having been said, those categories are, to use a term that we were talking about yesterday in the seminar, those are descriptive. They're descriptive in the sense that I've made a claim that those are the important ways of dividing things up, but I can't prove or disprove it, or at least I haven't proven or disproven it. Right? I can't prove that your model is going to be bad if you don't include identity. In fact, it turns out identity is actually hard to identify, no pun intended. Right? So those are descriptive categories. The claim is that the links between these things are more important than the things themselves. So the things that you identify as linking, you could use the concept of skills, knowledge, values, and identity epistemology if you want. It might be in a different domain or a different context, a different set of things matter. What the technique is doing is looking at, is design, anytime what you care about is the structure of connections rather than the things themselves, which is a general property of complex thinking. So think about the skills, knowledge, values, and so forth as a kind of heuristic. The one that's usually the most valuable in that context is the epistemology, because people leave it out, right? And they tend to focus just on the skills and knowledge. Now you could show, for example, that skills and knowledge give you an impoverished model. Right? The way that you would do that would be throw away all of the categories except skills and knowledge, construct your model, then include all the other categories, construct the model again, and show that you get more or better information by including the other things in the model. That would show you that skills and knowledge aren't enough, for example. Yeah.
Have you seen any more or less stable patterns in different groups? For example, between beginners and more.
Yeah, the short answer to that is that we haven't looked at enough domains yet. So in order to draw that kind of conclusion, right, you would want to be able to hold constant for or control for the fact that you could be looking at different levels of student, so high school students, secondary students versus college students. The different domains that they're working in, right? So engineering or urban planning and so forth. And there are probably other things that you need to take into account as well. We don't have enough, we haven't had a chance to be able to sort of control for those things experimentally enough to draw conclusions across these different interventions. We have a proposal that, it just got not funded, and we're gonna try again, but to build 2 games that are targeted for the same population of students on the same issue, but from a different perspective. So one from urban planning and one from engineering. That would be the kind of data that we might be able to use to draw a more general conclusion.
Because that could be data to inform you how to construct and design courses.
Yeah, absolutely,
Yeah.
absolutely. We don't have, this isn't generalizable in that sense yet, right? But we don't have enough data, we don't have the right type of data. But yes, eventually I think that will be the case. I mean, one of the things that I suspect is gonna be, we're gonna see is that, well, as you saw in, what was it? I think this kind of distinction, right, is gonna characterize success versus failure, which is, that's more about the overall density of the network than any particular, than any particular connection, right? You don't need a very sophisticated mathematical model to say that's not as good as that, right? It doesn't matter whether you can measure almost anything about those two at that point. So I think that those very crude distinctions, sort of broad scale distinctions, are going to be easy to find. What this will tell us is more subtle things, like for this particular game, this part right here has this effect for it. Those kinds of things. I think it's
I was thinking something I heard some days ago from the language department. There's a long debate on if you should learn grammar before you start to talk the language. If you start talking the language and then to learn the grammar. And it has been a rather huge shift, and now grammar is coming back. And now it seems like some parts of the grammar is more important than others. For example, in English, if you train grammatically the in form, it doesn't help very much. But to know something about singular and plural endings help a lot in the beginning. So it seems like some parts could support.
right. Yeah.
And some efforts are just useless.
Right. Right. So a way of thinking about this. So I see your point, but in order to answer that question, for example, forgetting about the technique, right? You really actually have to set up some kind of experimental conditions where you tried one or tried the other. Right? What this is useful for doing is modeling or measuring not just the end product of something, but its trajectory over time. So it doesn't necessarily change the need to set up the conditions of the experiment thoughtfully, but what it does is it gives you more data out of the experiment. And a way of thinking about that is, something like this to work, and similarly learning, English grammar, it takes hours and hours and hours and hours and hours. So the classical psychological experimental model that says, I'm going to do this, I'm going to do it with, 50 kids, each of them is going to spend a half an hour on this, and I'm going to have a carefully designed treatment and control group, won't tell you very much about what happens after 15 or 30 hours of doing something. So you need to be able to get more fine-grained information about it, but you still have to, in some ways, set up the experiment so that you actually see the comparison. So we haven't taken a break in our hour and a half so far, so I don't know whether or not we want to.
So perhaps we just take a break now and.
All right, and then I know I'm going to be having some lunch, I assume, with some folks, and then the seminar will pick up at 1. So I'm happy to hang around if people have individual questions for a few minutes, but otherwise, thank you all for coming. I really appreciate it.
Thank you for coming.